So where did we left off? So luckily I took some notes, and basically we got through the file reading and writing. In fact, so we got through file. Um, so that's all good. We can pretty much close that out. And then I believe, finished clean. Though I could see a scenario where we might want to add some more to that. But for right now, it's just these two functions, which is kind of wild. But so we're reading in the data from the files, from these files, and then we're cleaning them up to set them up to train our models, our RNNs. So again, that's so we take the stories in, we convert them to a big character array, which is literally just every word, every character in the story in sequence in an array. And then we build these dictionaries, which is character to index and index to character, back and forth. You need both ways to train a model. And yeah, that's pretty much clean. Then we started on model.py. Um, yeah, so we have create sequences. Again, as a reminder from last time, sequences, what we're talking about here is the way we train a neural network using text. Most natural language processing is you take a sequence of words, characters, whatever, and you feed it into the model, and then you tell it when you have these 50 characters in this order, then the next character is this one. And then you do that for the next 50. You shift by, in our case, 3 down the story. You keep feeding the next 50 in, the next 50 in. You keep feeding it the y values, which is the next character that's here. And so at the end, you build this gigantic array of sequences to next character pairs. And that's how you train the neural network. So that's what create sequences does. Vectorization is a little harder to explain. So let's see. Oh, I need to delete this. I don't want that in there. So vectorization is essentially breaking down. So we create these two arrays. These are NumPy arrays full of zeros, and then we build these vectors essentially. And the way we do that, so for each batch size, we enumerate over our sequences array, and then we store at position I of t character index c equals 1. So we're building this, we've got this array of zeros, and we're flipping specific bits in the array to 1 to represent that was the character that was chosen. So that's how the math is done, right? We've got a array of bits basically, and those bits train the model over time. That's how we do, because neural networks, machine learning, it's all math, right? You could do something with like ASCII numbers or something like that, but in our case, don't need that. We can literally just do zeros or ones, good to go. So we build an array, we flip the bits when our character matches. That's our character dictionary. And then same thing with Y. And this is what the model reads in. Then we have shuffle and split. So if you're familiar with machine learning stuff, you have a training set and a test set, and you generally want to randomize that. And so let's say we have 100% of data, we take 95% of that data, we train the model, we use the other 5% to test the model and to check our accuracy. So as we train, you'll see an accuracy number. It'll give us feedback basically. And then this is where we left off with the build model. This is just the kind of building the object itself, the model. In our case, we're using TensorFlow as our machine learning, our deep learning library. And so we started with this sequential, which is just a sequential neural network, and we added these layers. So we have an LSTM layer, that's long short-term memory. I go over a little bit about that, not a ton, just because it's a lot to explain. But in the last stream, but just know that we have an LSTM layer of 128 nodes. The input shape is our sequence size, and then our length of our character array, which is essentially our vocabulary. We have activation function, which is basically what's the function that activates a specific node. And then so we have two of those layers, and then we have a dense layer, which is just kind of a dummy layer of you know of nodes with an activation softmax. And then that's our model. So from here, I have our note. Functions we still need to train. Model. We need train model. We're going to take what we had before and clean it up a lot, I hope. We need our sampling function, which is essentially a approximation of a softmax. We're going to basically implement it ourselves. No reason not to. And you'll see what that is. That's pretty cool. And then I need to throw together a load model and load continue because whenever we build these models, they sometimes take a long time to create, and we don't want to have to train it every time. So what we can do is we can load it, or we can train a model, write it out to a file, and then load that later so we don't have to retrain. And then we'll have to do a generate text. So I don't know if we'll get to all this today. I can only stream for probably about an hour and a half, but we will try to get through most of it. We may be able to. We're kind of cheating because we've got old code. So and then once I get all that written, I'm also going to train a big model off stream once I think we've got the right setup, and then from there I'll come back and we'll generate some words, see how well the character-based generation does. As a reminder from last time, I had written all this code a long time ago, and I was using word word tokens, whatever you want to call it, word sequences, but it wasn't working the best for various reasons. I'm sure some of it was model tweaking I needed to do, some of it was parameters. And I got to a point where it almost looked like English, but it still wasn't quite there. But I've seen a lot of models that use a character-based, sequence set. So that's what we're doing here. We're going to see if that improves our model and makes it actually generate, words. Actually generates Edgar Allan Poe text, which is the overall point. So, all right. So we need to do train model, which is a big boy. Okay, train model. So I'm gonna close this out. What will that Control F4? I gotta learn all these keyboard shortcuts, which is gonna take a while. All right, so let's just call it train model again. And we're gonna take, so here's the classic question of what do I want, like, main to have to call. In this case, this is kind of a toy repo, so it really doesn't matter. When I previously wrote this code, I said, well, I want to just be able to give this a story array and a save location and have it do the rest. Maybe that's fine. There's some design principles there that I don't think are necessarily great, but whatever. It doesn't matter. Like we're just building a thing for fun, so it's kind of whatever. But so why don't let's do story array for now, and then we may change that in a second. And then yeah, model save location. Also, apologies, I barely work in Python, so I'm gonna not type stuff correctly all the time, constantly. Okay, so build word arrays, which we have a different here. So build word arrays gives us next words tests, sentences tests, word indices, and words. Okay. So what was, so here's, I've got the old source here. Let's look at clean. Okay, it's not in clean. It wasn't model though, right? Or was it? Oh, yeah, it was. Okay, so build word arrays is taking stories to words arrays, which we don't need to do here, right? We have that in clean, don't we? Stories to char array, yeah. Okay. And then build word dictionaries, which is fine. So we have build character dictionary. Then create sequences. Yeah, I think I can do most of this manually in here. So we do need char array equals stories to char array story array. Okay, and then we want to do this is oh build word dictionaries. Okay. Why is my yeah, this is classic Vim stuff of not okay. All right, so control 1 and 2. All right. Eventually get it. All right. So train model, character array, and then we want build word dictionaries. So we want char indices, indices char, and then char. Or no, I don't think we even get that. Build char dictionaries. Char array, right? Isn't that what it takes? Yeah. Yeah. Okay. Yeah. And so in this case over here with the word setup, we needed to filter out ignored words. And the reason we did that is because without that, our training set was just gigantic. There's obviously many more many more words than there are characters. So our training set was just gigantic when we took every single word. So what we did is we filtered out words of specific frequencies. So, for instance, if Edgar Allan Poe only used a specific word 4 times in all of his writing, we would filter that word out. But we don't need to do that with characters because we're just working with a certain character set, probably roughly around 60 or so characters. It's more than the English. We're talking about the ASCII set, so that's upper and lowercase, plus comma, period, whatever, general stuff. And so we don't need to do ignored words, I don't think, because I think our training sets are going to be small enough where it won't matter. Um, so we didn't need that in our build char dictionaries. So, all right, so we have that now. Now we need to create sequences. So sequences and then next chars. So we took a char array. All right. And then, so this next one is split, isn't it? That's, yeah, shuffle and split training set. All right. So sequences train, next char train, sequences test, next char test. What's it called? Shuffle. What's it take? Yeah, okay. Big long line, but that's okay. All right, so now we have our training X and Y. We have our test X and Y's. And that's what field word arrays returns. So let's go back to train model. All right, so now we need our model. And it took a char array. So it's our char array. All right, so from here we need to compile the model. So you build out the objects and then you run this compile function on TensorFlow models. You give it a loss function, which for right now we're just going to do the same thing I did last time. This might be a parameter we mess with later, but we have to give it this. So we're just going to use binary cross entropy, which is a big fancy loss function. I don't know the math, or I don't remember the math. I used to know it, but don't necessarily need to explain that. There's an optimizer function. There's one called Atom that a lot of people use. There's other ones as well. And then there's this metrics. And what this is how the model should know how it should take in feedback from the test set. So we're just going to tell it to go by accuracy, which is a built-in, built-in metric from the training that comes with after tests, right? So it's going to take in feedback from its accuracy metric to know, do we need to stop? How well are we doing? Whatever. Okay. So I need to stop using my mouse. What's the point of M if you're going to use your mouse, man? All right. So model compile, file path. Oh, that's for checkpoints. Oh, I see. Okay. I won't implement checkpoints yet. So checkpoints are good if you're going to be building a really big model. You can save checkpoints periodically, so you save off the training you've done so far. And I'm not going to implement that just yet. If I end up training a model for more than like an hour or so, basically it's to keep a point in time where if something fails, it crashes, your computer, your electricity goes off, whatever. You have a place to start back so you don't lose all that time. So if I'm going to train like a model for like an hour or something, I'll probably do that. Anything less than that, just, don't need to do it right now. So the other thing we do here is we do this early stopping function. So that is a way to tell the model that, hey, if you do 5 epochs and your value accuracy does not improve, just stop. We're not getting anywhere. Just stop early. There's no need to continue training. You will find in training models a lot of times that the training doesn't, like, every pass doesn't even improve the model. In fact, you can get to a point where you do what's called overtraining, where you have dialed in so much to your training set that you're no longer good at generalizing data. You're essentially just training to detect your training set, which is not what we want. We want to be able to use this outside of our training set, right? Obviously. So we're going to do an early stopping function. So it's tf Keras callbacks. These are callbacks that are passed to the fit function that we're going to do in a second. So our monitor is going to be value accuracy. I think what that's called. Oh, no, I think it is val, yeah. I remember they changed it. It used to be val ACC, now it's val accuracy. And then we're going to give it a patience, which is how many epochs it will wait before it kills it, it stops its training. I'm going to do 5 for now. That's fine. All right, so we have callback lists, so we need to do that. even with just the one, we'll do this, and then we'll just we'll add more later. Okay, so our model.fit is a big boy. So this vectorization, oop, vectorization function. All right, so we need to pass sequences, next char array, batch size, char array, and yeah, the char. Oop, hit a button. Char indices. Oh, that's what I did. I accidentally kicked off Python mode. Okay. But that reduced the size of my font too, didn't it? Or am I crazy? What happened? I'm gonna kill that. Oh, all right. Okay, so the model.fit has a lot of parameters to pass. The first thing you pass it is a well, you have to pass it the x and y values. In our case, we're using a generator function called vectorization to do that. And we built that earlier. We looked at it a minute ago, this one. So we're going to do that. And so it's going to call that every time. Okay. And then we have steps per epoch. In our case, that's going to be the length of our sequences. Divided, right, divided by number of epochs plus 1. Okay, and then just like we have over here, epochs is number of epochs, callbacks is our callback list. Our validation data is also our vectorization function, but this time with our tests, our test sets. So with sequences, tests, next char tests, maxlen is sequence size. I changed that that constant just because it wasn't very descriptive. And then char array. Oh yeah, and then same thing. Word indices char. I keep fat fingering that. Okay, validation steps, same thing. Okay, and then, so yeah, that finishes out our model.fit. Then we want to do model.save in our model save location. And then, because we want to, we'll turn them off. All right. Okay, so that is our train model. I'm very interested to see, one, if this runs. Oh, it's complaining. That's fine. You can complain about that. All right, so let's do this. Let's. Oop, wrong button. Oh, right. Let's train model, story array, model application. Okay. Mm, we'll just give it a, I believe it's an H5 type file. All right, let's try to run that. Maybe it'll up on us. These are warnings just because of GPU stuff. Long story. Test array is not defined. Oh, text array, my bad, not text. Gotcha. It even knew. It even knew and it didn't save me from my own mistake. Call yourself a language. Hmm. Sequences array is not defined. Really? Oh, they're not arrays. I just named them. I see. Okay. Well, if you're gonna be difficult, did I really just name that next char though? Next chars. I see. Okay. All right. Did I do that anywhere else? Bro, get out of the way. I don't think so. Oh, yeah, right here. Next chars. It's like, what are you talking about, man? There's no such thing as next char array. Just making shit up. Okay. Oop. Wait, sorry, where did I do that? 68. Test. Did I not save it? There we go. Wait a minute. What just happened? We did train the model, right? But it did it like instantly. Hmm. I expect there to be training output. They're not. Something is wrong. Oop. Or I expect an error. Um. Sorry, what? Keras API v2. Keras has no attribute layer. Really? Oh, it's layers. Man. I take it back. We should be using PyCharm. All right. Yep. I did mean that. How'd you know? Once again, it knowing exactly what I meant and not doing it. I'm impressed it knew what I meant, but I'm unimpressed that it didn't fix it for me. Well, while this runs, how are we doing out there? They feel free to ask any questions. I'm not, I wouldn't say an expert in this stuff. I definitely don't. It's more of a hobby, but um, I've read a decent amount about it. So, oh, okay. What do we got here? File path. Did I give it a file path? Hmm. I'll check one has a. Really? Boy, it'd be nice if I had PyCharm right now. I didn't know Model Checkpoint had a. Hmm. Was saying Model Checkpoint and it missing one required positional argument file path. Is that true? Let's look that up. Sorry for the quick flashbang. tf.keras.callbacks model checkpoint. Oh, sorry. Oh, wait, I don't think the stream can see that. Oh, yeah, you can. Sorry. um, sorry for the flashbang. Okay. Let's see. Oh, yeah, look at that. A file path. When did they add that? That's cool. Oh. Oh, I know what I did. I was looking at the wrong line. I typed model checkpoints when I meant to type early stopping. Hey, look at that. All right. That's what I meant. See, again, it just didn't know what I meant. That one it didn't figure out though, which, hey, if it could have figured that one out, good on you. That would have taken like some like here's what source he has open and he's typing in this window but doing nothing in that window and so he needed to like, you know, well clearly he's trying to copy this side and let's look at this other line and whatever. All right, what do we got here? Allocation of a lot exceeds memory. Um, oh, to mention that the training when you have large sets could shut my stream down. So apologies if that happens. Um, up RAM. So what is happening here? Why are we running so slowly? Do we have our? No, we don't. Hmm. Oh my. Okay. Hopefully you can still hear me. I just killed that. Maybe we have too much going in at the moment. Let me break this down to just one story. So let me. Okay. So I moved all of them but one story into there. That's interesting though. I wouldn't have expected We might be doing something wrong then. So char array. Hmm. So this is all characters. I think we actually need the vocab. Yeah, we don't have the vocab. So like over here, we have this words, right? And that comes from build word arrays. So yeah, we need to like, all right, let's do that. Let's look at build word arrays again down here. Build word dictionaries. So we could, let's look at build word dictionaries. No definition found. Yes, there is. Don't give me that. Clean? Build word dictionary. Yeah. Okay. So yeah, we need to. That's what we need to do. We need words set of word array. Yeah. Yeah. Okay. Sorted set. Yeah. All right. So let's put that in here. Um, we'll call it char vocab. I can just do that, right? Yeah, surely. All right. So then we want char vocab there. We also want it here. Is that right? Let's look at vectorization real quick. I need to remember the keyboard shortcut. Batch size char array. Yeah, I think this actually needs to be char vocab. Nope. Okay. That was char vocab. I need to do it here too. Ah, Vim strikes again. Okay. Char and C's, that's good. Is there anywhere else where I was using char array and I shouldn't? Yeah, that's got to be char vocab too, right? What is it over here? Oh, I want model. Yeah. Okay. All right. This makes a lot more sense. Okay. All right. Is that might be everything? All right. Hopefully we don't crash this time. Yeah. So, um, yeah, that's my bad. That makes so much sense. Why we were crashing. Where was from? Vectorization chart to see C equals 1. Out of bounds with size 100. Chart indices of C equals 1. Enumerate sequences array. Oh. Wait, does that make sense? Hold on. Are we hitting that on the last one? I think I had this exact same problem. Um, all right, let's see what we end up with. Wait, sorry. I gotta go back here. I don't like the way they do that. I wish, I mean, I could probably, I'm sure, write the run scripts to make this easier, but whatever. All right, so what's in X? So it's size 50,000. Holy. Hmm. Is that right? X is 50,000? Yeah, that is right. Okay. And then, all right, so out of bounds for axis 2 with size 1, so it's the T. So our sequence array index, oh, T is starting at 1. Do we want to do T minus 1? Is that the problem? If someone sees something I'm obviously missing, please let me know. That doesn't, why is T starting at 1? Or is it starting at 1? Ah, I did it again. Well, it starts at 0. Okay. No, so we definitely don't want to do that. Holy moly. Okay. So it starts at 0. When do we go out of bounds? So shape is 20, 25, 100. Makes sense. Um, oh, axis 2 is the third. Oh, I see. Okay. Yeah, that makes sense. So character indices C equals 1. So let's loop through there. Oh. Hmm. All right, I want to say it one more time in memory. Yeah, at this rate, definitely not getting this finished today. So, all right, so our T is 1, I is 0. And char and C is E. I really don't have an E. Okay, maybe something's up with our dictionary. Wait, it's only length 100. Hmm. Okay. Oh, I see. So in our sequence array, our next one is E. But E is not in our char indices. That can't be right. There's no way. Wait, yeah, it's right here. Okay, so E of char indices should be 4216. Oh. What is with these indexes? Oh, okay. So that's a problem. Our indexes are gigantic. Um, yes. The same problem strikes again. I see. Okay. So where we're doing build character dictionaries, which is in train model, we don't want char away, we want, right? Char vocab. Wait, no, that can't be right. Wait, what? Oh, okay. Let's do this. Let's do this. Okay, I'm pretty sure this is what we need. Um, shoot. All right. D, P. Okay. Good old Vim. All right. Yeah, so I think we want this, right? Yeah. 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 That's definitely what we want. Okay. And did we do that in this one? Hmm. Yeah. Okay. Yep. Same thing. Whew, mystery solved. Okay. So, in case you weren't following along there, I was passing the full character set, which then built our dictionaries. And so our indexes were gigantic because um, the way it was adding to the dictionaries, and we're talking millions of letters. So that needed to be char vocab, and then char vocab, we can find it first from the character array, and then build our dictionaries from that. Okay, cool. So does that completely fix our problem? I think it might. Let's see. Again, if it starts training and the stream goes down, sorry. Oh, we got an epoch. We have training. Let's go. That bad boy run. It's gonna be a while. That's pretty good accuracy though. Hmm. I'm liking what I'm seeing. That that accuracy number when I was using words very rarely got above zero point 0.1. And this is after just a few seconds. So if you're wondering what's going on here, it is taking our sequences, passing them through the model, and then it tests itself. That's how this accuracy and loss gets updated. So most of machine learning can come down to we have a mathematical function that is trying to minimize our loss. Loss is defined as, different ways, but in like linear regression, it's defined as our distance from our where we should be to where we are, I guess, if that makes sense. And so the function is written to minimize that distance over time. Our accuracy is how well we did against the test data. So because the test data, the y's are known, so you can feed in the x test, and you already know the answer, and you see what the model gives you, and you see how close you were. So this looks really good. I'm actually going to kill this right now, and then try to finish up some of this code, and in the next 15 minutes or so. And then tomorrow I will run a big long test, and we will then look at this and see what our results are on Thursday. So I'm going to kill that. Let's go ahead and do the rest of our. So let me look at this real quick. All right, so we did train model. We need to do sample and load and continue. Okay, so we'll do these three. We'll do these, and then generate text. I don't know if we'll get to it or not, but all right, so let's throw in sample real quick. Sample is one that's not too big of a deal. There's a lot of math behind it, but it's not too crazy to write. So okay, so we have preds, which is our predictions, and we have this temperature. So preds is our predicted x values, or sorry, our predicted y array. That's what it is. And temperature is this, geez. A lot of this math comes from a few blog posts, where there was some dudes who figured this stuff out. I don't have the links anymore. I used to, but and one thing they did is they had this temperature value, and you can use it to adjust the this sampling basically. So it's just another parameter to adjust. All right, so first we want preds as array preds as type float 64. You know what? Actually, this code is not going to change. There's no world where we change this. So I'm going to just copy it. And hope that I actually did just copy it. Oop. Okay, I gotta figure this out. There's something about Vim where when I do YY, I don't actually copy after doing Shift V. All right, does that work? Okay, that worked. Yeah, I don't know what I'm doing wrong when that happens, but all right. So there's sample. Hey, we're done. Look at that. We copied it. All right, so we do load model and load continue. So load model's the easy one. In fact, this one won't change either. So let me just. All right. So just to explain this function real quick, it takes in a checkpoint as said earlier, and we just literally call the model.loadModel on that checkpoint, and it loads it into memory. So our pre-trained models can just be loaded up. So easy enough. Load model and continue is effectively the same thing, but we can give. So yeah, I think so. Train model. Let me go look at that real quick. Train model. You give it this save location, and what I'm not sure about is, yeah, I guess it'll just load the model and then rewrite. Okay. All right. Don't even need to worry about that right now, I think. Um, yeah, so maybe we will have time for generate text. Generate text, kind of a mouthful. All right. So we have our model. We have our Why did I do it this order? Char indices, uh, indices char. Okay, and then we have a seed. That's basically what will kick off the generation. What will be our starting sequences? Sequence length. Is that just? Yeah, that's got to be our. Yeah, our constant. Then there's this diversity parameter. There's a quantity, so that's how many words you want to produce. And then there's our vocab there. All right, so let's look at this. So we have to do c-split to split it into sentence, but actually we actually may even need characters, right? What did we do in file? Split that up eloquently, which I'm sure we did. Oh, it wasn't in file, it's in clean, right? Oh, okay, yeah. There. So we just need seed seed chars equals seed dot split. Actually, yeah, let's do it that way. Let's see equals seed dot split. C chars. So yeah, we'll just do it the same way. Forward and split seed. Char list equals word. X and word. Wait, what is char list for? Wait a minute. What? I don't need that. Yeah. What am I doing here? What is this? The hell? Man, sometimes when you look back at code you wrote, you're just like, what was I thinking about? Like, what? This doesn't make any sense. Uh, oh, I do need to define char seed. Oh, yeah, I don't wanted to name it seed jars, not char seed. Okay. All right, so we have our seed broken up into characters. Let's go back to generate. Mm, okay. So what are we doing here? Let's talk through this. So so basically iterate over a quantity. Xpred. Okay, that's right. Xpred. Yeah, we have to build Xpred. This is, I believe, gonna remain the same. Yeah, yeah, that's all the same. Okay, every time. All right, so let's go through here. Word indices. It's char indices. Next char. Okay, it's not. We don't want to iterate over sentence. We want to iterate over C chars. This is gonna be char. No, is that a built-in type? I don't actually know Python. Right, so that'll be char. Next index, next char. Preds, mono predict, xpred, correct, looks good. Sentence, that should be, let's see. Right? Oh no, it should be char. It should be C chars. I might have this wrong. We'll have to test it and see. I don't want to do that anymore. Um, oh, yeah, I don't want to do any of this. Yeah, let's just delete all that. So we don't need that. Ah, jeez. Okay. So we actually do need to print, though. We need to print our character. Hmm. We'll do 100. Try that. All right. There's 0% chance this works first try. Oh, I need model. Okay. All right, we'll work on a seed in a second. Sequence length, diversity. What did we use over here? One, 250 quantity. Okay. And then okay. So got a little cleaning up to do. We need our indices. Look at this over here. All right. And then we need seed. How do we do seed over here? Oh yeah, I just took a random. So I want more than 400 characters for the seed for sure. So let's do that. We'll do the same thing. How many characters? 1,000? I guess. Okay. So does that take everything? Let's try it. And hopefully this works first try and we'll be done. Yeah. Oh, weird. Didn't. Oh yeah, I need to do some imports. That's the only one I need. Yeah, I think so. See, that's the thing that PyCharm would have told me about. That is, you know, a small price you do pay for, um, right, gotta train. Okay. I think we're probably gonna call it there. Like I said, I'm gonna run a training model probably tomorrow during the day and, build up a big model, and then we'll see if generate text works. It's it's very unlikely it does first try, but we'll see. And then we'll see what kind of text we can generate. Man, I love this accuracy though. That looks great. That's gonna be so good. We may actually be able to print some fake Edgar Allan Poe. That will be very hype.